Hi, we are Alejandro Patiño and Jenny Gonzalez, and today we are going to explain exercise number 5, which is the next one. Silicon thin films are commonly formed by the chemical vapor deposition of silent vapor into the surface of a wire in electronic devices. This surface reaction is usually carried out at a very low pressure and a high temperature, and is very rapid, so as a silent concentration on the surface is approximately null. Consequently, the molecular diffusion of the silent vapor to the surface of the control the rates of silicon film formation. A mixture of silent and nitrogen gas at 1 to 5 molar ratio flows into the reactor. The film is located 5 centimeters below the gas inlet and determines the flux of silent vapor in the formation of the film. Suppose there is no nitrogen in the reactor when determining the diffusion coefficient. Now that we know the problem, first the diffusivity of the silent must be calculated by Lennard-Jones. So we have the following data. We have pressure is equal to 166 Pascal, temperature is 900 Kelvin, and the following silent constants, they are the ones you can see on the screen. We also have molecular weight of silent and hydrogen. In order to calculate the diffusivity, we must calculate kT over E, and then we must interpolate. Then the interpolation is equal to 0.8677. Then we substitute all the values into the diffusivity equation and calculate, as you can see. So the diffusivity of silent is equal to 0.15376 square meters per second. After obtaining the diffusivity, we have to calculate the flux of silent vapor, but first we have to understand the reaction. The silent reacts producing solid silicon and releasing hydrogen gas. Then, with the balance equation, we make the NiC over the sum of NiC a constant by dividing over the equivalence of A. Now we must calculate Y1 and Y2. So, the sum of NiC is equal to negative 1. Now we must calculate Y1 and Y2. We know that the silent current is 1 to 5, so we obtain that the concentration of Y1 is equal to 1.2. We know that the concentration of the silent open separation is equal 0. Finally, we replace all the values in the flux equation and calculate. The silent vapor flow is 1.2434 by 10 by the minutes 5. And that will be the flux of silent vapor in the formation of the film. Thanks. As you can see in the illustration, an inlet stream is observed, which is the silent. Then it collides with the wall of the reactor, forming the solid layer, releasing molecular hydrogen and silicon.